All right, so get this. We're going to be diving into, well, the idea that Mars, that rusty red planet we see today, might have once had lakes, like actual lakes.
It really is amazing, isn't it?
Yeah, I mean, it sounds like something straight out of science fiction,
Mhm.
But when you look at the research, it's pretty convincing.
Oh, yeah.
So for this deep dive, we're using the Wikipedia article on Martian lakes.
Oh, great choice.
And let me tell you, it's packed with all sorts of incredible images and research findings.
It really is. And, it's really a fascinating journey how our understanding of Mars has changed over time.
Well, yeah.
If you think back to the 60s, those first images from Mariner 4, Mars looked like, well, kind of a desolate wasteland.
Really?
Yeah, just craters and dust, no water, no signs of life.
Kind of a bummer, huh?
Yeah, huge cosmic letdown.
Yeah. But thankfully, scientists didn't just give up, right?
Right.
They kept digging literally and figuratively.
Mm.
And as technology got better, we started to get, well, like a whole new view of Mars.
Yeah.
So how did we go from barren desert to potential lake paradise?
Well, it's all in the details, right? So later, spacecraft had much better cameras, and they started to show hints of ancient rivers
Oh, wow.
and what looked like dried up lake beds.
Really?
Yeah, and then there's the ice, too. We now know Mars has quite a bit of ice beneath the surface, which just, well, it points to a wetter past.
Okay, so let's talk about these lakes. I mean, on Earth, lakes form because of rainfall, rivers, the whole water cycle. But Mars isn't exactly known for its, tropical climate.
Right.
So how did these Martian lakes actually form?
That's where things get really fascinating. You see, unlike Earth, which has a large moon to stabilize it, Mars doesn't.
Hmm.
And that lack of, a gravitational anchor, well, it's led to some really wild swings in its axis over millions of years. Like, imagine the poles pointing towards the sun.
Whoa.
Yeah, so these shifts would cause some dramatic climate changes with periods warm enough for liquid water to actually exist on the surface.
So are we talking like massive Earth-sized lakes here, or more like little puddles in a Martian desert?
Oh no, think much grander than puddles. We're talking about some seriously impressive bodies of water, some might have even rivaled the Great Lakes here on Earth.
No way.
Oh yeah, and the evidence is right there on the Martian landscape. You've got dried up riverbeds, channels that wind just like our own,
Hmm.
and those fan-shaped deltas. You know how deltas form, right?
Yeah, remind me.
Sure, so they form when water flows into a larger body, depositing sediment. And on Mars, we see these deltas right at the ends of channels that flow into depressions,
Hmm.
which is a pretty clear sign that those depressions once held lakes.
Makes sense. So we've got the clues, but where are the prime suspects? I'm ready for a Martian lake tour. What are some of the most promising spots where scientists think these ancient lakes actually existed?
All right, buckle up. First stop, Valles Marineris. Now, this canyon system is colossal, like the Grand Canyon on steroids. It stretches thousands of kilometers across the Martian surface. Scientists believe that it could have been home to, well, a series of interconnected lakes. And these lakes, they would have been filled with so much water, it would make even the largest earthly lakes look
A
tiny.
Martian lake? Jane, that's crazy.
Well,
So what makes scientists so sure that Valles Marineris was once this watery wonderland?
Okay, so picture this. Layered deposits and minerals that can only form in the presence of water, and even possible evidence of, well, sulfates, like epsomite and kieserite. Ever heard of those?
Can't say that I have, no.
Well, they're basically bath salts.
Wait, hold on. Mars had bath salts.
Well, maybe not for spa days, but the fact that these minerals are there, it's incredibly exciting.
Yeah.
It tells us that water played a big role in shaping the landscape of Valles Marineris. And within this vast canyon system, there's a place called Melis Chasma, the deepest part of the canyon. So imagine a lake so deep it could hold enough water to fill Earth's Grand Canyon many, many times over.
Wow. Okay, it's mind-blowing. But enough about bath salts for now. Where's the next stop on our Martian lake tour?
All right, let's head over to Hellas Basin. This is another massive impact crater, and we see things like possible shorelines, signs of ancient glacial activity, and even layered deposits within smaller craters like Turby Crater. And those deposits, they look very similar to deltas on Earth, formed by water flowing into a larger body and carrying sediment.
So we're talking about another potential megalink here.
Yeah, but you mentioned glacial activity.
Right.
So how does that fit in? Was Mars just a giant snowball at some point?
Good question.
Well, that's the fascinating part. While Mars might not have been a complete snowball, there's evidence that suggests it did go through periods of intense cold where glaciers carved their way across the landscape. And of course, when glaciers melt, you get meltwater, which can feed lakes and create those features that we see in Hellas Basin.
All right, this Martian lake story is getting more and more intriguing. What else have you got?
Well, this next stop is special because, well, it's where the Curiosity rover is right now. Get ready for Gale Crater.
Hold on, Curiosity, the one that's been sending back all those incredible pictures. What's it found in Gale Crater?
Gale Crater is a perfect example of how sending rovers to Mars can completely change what we thought we knew.
Yeah.
Curiosity has sent back proof, solid proof, that this crater was once a freshwater lake. And not just any lake, one that might have existed for a very, very long time, maybe even millions of years.
Okay, now we're talking. But how can Curiosity tell us that? I mean, it's not like there are signs on Mars pointing to a lake.
Right, well, it's all about the clues. Curiosity found clay minerals, which, as you know, only form in the presence of water. And not just that, it also found deltas, which means the lake level fluctuated over time, just like lakes on Earth do. Think of it like reading the diary of a long-lost Martian lake.
Wow, that's incredible. So Curiosity is basically confirming what scientists have suspected all along. Ancient Mars was a much wetter place than we thought. These lakes, they might have been around for a really long time.
Exactly, and that's just the beginning. There are even more intriguing Martian lake sites to explore, each with its own unique story to tell.
Well, hold on to your Martian rovers, everyone, because this deep dive is just getting started. We've got more lakes to explore, more evidence to uncover, and who knows, maybe even some hints about the possibility of life on ancient Mars. Stay tuned. Okay, so we're back and ready to continue our Martian lake expedition. Last time we were pretty blown away by that evidence from Gale Crater, thanks to the Curiosity rover.
Yeah, amazing stuff.
It's wild to think that a place that's now just like a dry, dusty crater was once, a real lake with fresh water.
It really does make you rethink what you thought you knew about Mars, doesn't it?
Absolutely. And Gale Crater's just one piece of the puzzle, right?
Right. There are so many other cool spots where scientists have found, well, pretty solid evidence of ancient lakes.
Well, don't leave us hanging. Which watery wonder are we going to splash into next?
Okay, let's take a look at Holden Crater. What's so cool about this place is how clearly it shows the remains of an ancient lake. You know, it's like a Martian history book, just laid open for us to see.
Holden Crater, huh? Okay, you've got my attention. What makes it so special?
Well, imagine this. A colossal flood, powerful enough to carve out this massive channel. It's called Oases.
Wow.
And that channel, etched right into the Martian surface, tells a pretty dramatic story of a lake that once filled Holden Crater.
A Martian mega flood. Okay, now that would have been something to see, or at least, billions of years ago. Was it a sudden thing or something that happened more gradually?
It's kind of like a detective story, piecing together the clues from, what we see on the Martian landscape. So scientists think there was this network of ancient rivers, the Oases-Ladon-Morava system.
Okay.
And they drain water from another huge lake, probably in the Argyre Basin. So when an impact made Holden Crater, it blocked the flow of this river system. Like, it created a natural dam.
So water from this other lake was flowing into Holden Crater, like filling it up.
Exactly. It's like a giant reservoir. And this created a deep, long-lasting lake inside Holden Crater. But of course, all that water building up behind a natural dam, well, couldn't last forever, right? Eventually, the pressure got to be too much, and the water burst through the crater rim, creating that epic flood we talked about and carving out Oases.
Talk about a dramatic ending. And the evidence of this flood is still visible today. That's amazing.
Yeah.
It really makes you think about what other dramatic events might have shaped the surface of Mars,
Speaking of dramatic landscapes, let's jump over to a region called Western Elysium Planitia.
Okay.
This area has some really unique features that have caused a bit of a debate among scientists. Was it a lake bed? Or was it, covered in lava at some point?
Ooh, a scientific showdown. Okay, I'm all ears. What does the evidence say?
Okay, so picture a vast plain, but with, fractured plates and these strange, sinuous ridges that look a lot like, pack ice, like the kind you see on Earth.
Wow.
Some scientists think that this terrain was formed by huge lava flows that cooled and solidified.
It's like a Martian lava ocean. That's pretty wild. But what about the lake idea? What evidence supports that?
Well, there are some good clues that suggest a watery past for Western Elysium Planitia.
Yeah.
For instance, there's something called sorted patterned ground. You familiar with that?
Not really.
So these are like geometric patterns in the soil that form in areas where there's been, repeated freezing and thawing of water. And then there are these erosion patterns and what we call streamlined islands.
Okay.
Both of those things point to the presence of, well, water and ice.
So it's kind of a toss-up, huh? Lava flows or a giant lake? Which side do you think is more likely?
It's hard to say for sure. Both theories have their strengths, and honestly, we need more research to really settle the debate. But there is one pretty interesting feature in Western Elysium Planitia that might be a clue. Remember those rootless cones we talked about before?
Rootless cones, remind me, those are the cone-shaped mounds with pits at the top,
You
right?
got it. And they form when hot lava flows over ground that's rich in ice. It's the interaction between the lava and the ice that creates those distinctive cone-shaped structures.
Ah, okay. So the fact that these rootless cones are there, it could actually support both theories, both the lava and the lake idea.
Yeah, exactly. It's really cool how Mars just keeps challenging our assumptions and keeping us guessing. But let's not forget about, well, kind of the giant in the room here. Argyre Basin. It's another one of those huge impact craters like Hellas Basin, and scientists think it might have had a truly enormous lake at some point.
Okay.
We see evidence of like ancient river valleys flowing into it, suggesting that it was a major hub for water on Mars.
So another megalake, just like Hellas Basin. Man, early Mars was seriously soaked. But you mentioned that Argyre Basin formed after Hellas Basin. So does that mean the megalake in Argyre formed after the one in Hellas dried up?
That's a great question. It seems like Mars went through these like cycles of wet and dry conditions with lakes forming and disappearing over millions of years. So while we're still figuring out the exact timing, it's likely that the lakes in Argyre and Hellas didn't exist at the same time. And Argyre Basin, it's got some unique features that suggest it might have been a particularly icy place. Like we see these sinuous ridges that look a lot like eskers. You know what those are?
You refresh my memory.
So they're these long, winding ridges of sediment that are deposited by meltwater flowing under glaciers.
Okay, so like picture a giant frozen lake in Argyre Basin with glaciers and eskers all over the place. It's like a Martian ice age. Wild.
It really is. And this frozen landscape wasn't just limited to the megalakes. Let's take a look at a relatively small but interesting crater called Ritchie Crater. Here we see a really clear layered sequence of, well, sedimentary deposits, including those clay minerals we keep finding, which, as you know, point to the presence of water.
Ah, those telltale signs of water.
Yeah.
So Ritchie Crater was definitely a lake at some point. But you said it was relatively small, so does that mean it was a short-lived lake?
Mm.
Or could it have lasted for a while?
It's hard to say for sure how long the lake in Ritchie Crater lasted, but we do see what we call fluvial features. So those are channels carved by flowing water along the crater walls and the rim. And we also see alluvial and fluvial deposits. Those features suggest a history of water activity, maybe even a pretty persistent lake that was around for a while.
It's amazing how even these smaller craters can tell us so much about Mars's watery past. Makes you wonder what other secrets are waiting to be discovered.
Right. Speaking of secrets, let's talk about a location that has scientists really excited. Jezero Crater. Maybe you've heard of it.
Jezero Crater. That's where the Perseverance rover is right now.
Yeah.
So I've been following its journey. What's so special about this crater?
Well, Jezero Crater is kind of like a Martian time capsule, packed with evidence of a watery past and, maybe even signs of ancient life. One of the most striking things is this fan delta deposit that's full of clays.
Okay.
And that tells us that water flowed into the crater and formed a lake. And not just any lake, one that might have been teeming with microbial life.
Hold on. Are you saying there could be, like, fossilized Martian microbes in Jezero Crater?
It's possible. Scientists think that Jezero Crater was filled with water at least twice, with two channels, one on the north side and one on the west side, supplying the water. And just like we've seen in other craters, these channels have those delta-like deposits where the water carried sediment and deposited it in the lake.
So it's pretty clear that Jezero Crater was once a lively, watery place. And the fact that Perseverance is there, like right now, collecting samples and searching for signs of life, that's just mind-blowing. What else is there to discover about Martian lakes?
Well, buckle up, because we're going to talk about the granddaddy of all Martian lakes, Eridania Lake. This thing was bigger than any other lake we've discussed, and it might hold some of the biggest clues about whether there was ever life on ancient Mars.
Okay, I'm all ears. Tell me everything about this mega lake. What makes it so special? We're back, and I got to say, Eridania Lake, a Martian lake bigger than the Caspian Sea.
Yeah.
That's not just a lake that's like an inland sea.
Right.
Okay, I need to know more about this ancient watery giant.
It really does push the boundaries of what we thought was possible on Mars, doesn't it? Just imagine this, like, this vast, shimmering expanse of water stretching across the Martian landscape, Eridania Lake. It probably held more water than every other Martian lake combined.
Wow, that's a lot of water. So what kind of evidence points to a lake that big? It must have left some pretty serious marks.
Oh, it did. We see the same patterns we've been seeing in other lake basins, like all those valley networks that just stop at the same elevation. Just like they would if they were all flowing into a huge body of water.
Like that bathtub ring effect we've been talking about.
Yeah.
But Eridania Lake, this one seems like a whole other level. What else makes this lake stand out?
Okay, so get this. Scientists have found evidence of minerals that suggest there might have been hydrothermal vents in this region.
Wait, hydrothermal vents? Like those underwater geysers that shoot out all that hot mineral-rich water? The ones that support, like, entire ecosystems, even in the deepest parts of the ocean.
The very same. On Earth, those hydrothermal vents are teeming with life even in the most extreme environments. And the fact that these vents might have existed in Eridania Lake, well, it opens up some really incredible possibilities for life on ancient Mars.
This is amazing. So we're talking about a giant lake, maybe warmed by these hydrothermal vents and full of the minerals that life needs to, to thrive. If there was ever a place on Mars where life could have existed, Eridania Lake seems like the top contender.
It's pretty exciting, right? And remember, all those clay deposits we keep finding, Eridania Lake's got tons of them. And clays are great at preserving organic matter. So if there was life in Eridania Lake, those clay deposits might just hold the fossilized proof.
This is really starting to sound like a strong case for a habitable ancient Mars.
Yeah.
Don't you think? I mean, we've got evidence of lakes everywhere, some of them lasting for millions of years, and maybe even hydrothermal vents for warmth and energy.
I'd say so. But before we wrap up our Martian lake tour, there's one more stop. I want to make Columbus Crater. This one might help us understand how Mars changed from a wet world, maybe even a world that supported life, to the dry, dusty planet we see today.
Interesting. Okay, what's so special about Columbus Crater? Another potential hotspot for life.
It's definitely possible Columbus Crater is in the Memnonia Quadrangle. And it's got this really interesting pattern of layers, like clays underneath sulfates. This layered structure tells us that the environment changed, like shifted from wetter to drier conditions.
Okay, so walk me through this. What can we learn from these layers of clay and sulfates? How do they tell the story of a changing Martian climate?
Okay, so imagine a big deep lake in Columbus Crater.
Yeah.
And it's slowly evaporating over time. As the water level drops and the lake gets shallower, different minerals, they come out of the water and settle to the bottom.
So the clays formed first when the lake was deeper and the water was fresher, and then as the water evaporated and got more concentrated, that's when the sulfates formed.
You got it. And here's the really interesting part. Some of those layers in Columbus Crater, they contain gypsum. Gypsum's a type of sulfate that forms in relatively fresh water. So that suggests that even as the lake was drying up, there were times when the water was still pretty hospitable for life.
So even as Mars was drying out, there were still these like little pockets of potential habitability. It's like Mars was trying to hold on to its water even as it was becoming the planet we know today.
I like that analogy. And the fact that we see this clay beneath sulfate pattern in Columbus Crater, it tells us that this transition from wet to dry was probably a gradual thing, not some sudden catastrophic event.
We've covered a lot of ground in this deep dive, from huge canyons to massive impact basins, from hydrothermal vents to the possibility of life. The evidence for ancient lakes on Mars is it's amazing.
So what's the big takeaway here? What does all this tell us about Mars? And about our place in the universe.
I think the biggest thing to remember is that Mars is not this static, lifeless world we used to think it was. It's a planet with a dynamic history, a past shaped by water, ice, and maybe even life. And honestly, the more we learn about it, the more we realize how much we still don't know. That's what makes it so exciting, right? We're really just starting to understand Mars. And with every new discovery, we get a better picture of the red planet and our place in the universe.
I agree. And as we continue to explore with, robotic missions and someday even human explorers, the story of Mars will just keep getting more and more interesting.
This has been an awesome journey. I feel like I've learned so much about Martian lakes and about how incredible and complex the cosmos really is. So big thanks to you for, well, for being our guide on this deep dive.
The pleasure was all mine. And to our listeners, keep exploring, keep asking questions, and never stop being curious. The universe is full of amazing things waiting to be discovered.